Excellent. Good morning. My name's Oliver Morton. I'm another of the people from Nature here. I'm the Chief News and Features Editor, but I'm not doing this as a journalist. I will be your moderator. I'm also doubling as a visual aid. I thought I would provide you with an image of a natural scientist making a mistake. That's what this T-shirt is, for those of you who are aware of the antics of Professor Calculus in Tintin. The reason for doing this is that A, we're talking about risk, and falling over on roller skates is definitely a risk, and B, we're now moving from the natural sciences to the social sciences, where we talk about understanding and perception. I'm not going to say anything more about that except to enjoin you, and indeed the speakers, to remember that understanding and perception are not just things, but also processes, and they are processes in which we are now engaged. Our first speaker, I hope, is Paul Slovic, who makes his contributions as an expert on human judgment and on risk analysis, and looks at the perception of risk and also concepts of risk that come about due to exposure to technology. He's a professor at the University of Oregon, and he's also president of the Decision Research Group. And I hope he's here somewhere. Hi, Paul.
Okay, good morning. I'm going to give you a whirlwind tour of the psychology of risk. This is a bit of an overview of what I hope to cover. Complexity of risk, a little bit on perception of risk, issues of trust, democracy and process issues, and something called risk as feelings, and a couple of conclusions. I was searching around to educate myself a little bit about this field, synthetic biology, and I came upon this website, Synthetic Society, where it talked about a problem that we're addressing this morning, and raised the issue of scientific illiteracy as a major thing to watch out for, because the ignorant public might get unhappy about this technology, and this could lead to eventually to banning the research. Well, sure, most of us don't know, science behind this biology, but I don't think this is the problem. I think it would be a mistake for this community to really overemphasize this aspect of illiteracy. I mean, sure, knowledge is good, and more knowledge is better, but that's not the key to kind of smooth sailing with regard to technology. We embrace many technologies that pose risk, despite not understanding the science behind these technologies. And certainly computers and their components are one aspect of this, which we don't fully understand the workings of, but we certainly have embraced, and they can be used for adverse purposes, obviously. The same website talks about the objective to educate the public, and has a lot of good material in there. And I just highlighted the notion of education, openness, and involvement, which I think the research on perception of risk and acceptance of risk would second. But there was also something that struck me as surprising to see in this, and that is the ultimate goal is to formulate an approach that enables the technology to advance as smoothly as possible without impediment. Well, I hope that is not the ultimate goal. I mean, I think that is, again, a goal that will lead to trouble. I think for the technology to succeed, ultimately, the goal should be to enhance the welfare and well-being of society and people. I'm going to skip a few things because I know the time is tight. I've characterized risk assessment as a battlefield, and there's some lessons. I mean, we've been struggling with risk assessment and conflicts about risk for 30 or 35 years, and there's a few lessons I think that are worth considering here. The first is, don't count on risk assessment to ensure the viability of synthetic biology. Risk assessment is a wonderful tool. Risk analysis is a fine, is an important discipline, but it can only go so far. I mean, it starts with risk assessment, identifying risk. It provides information for risk management and decision making and deciding what risks are acceptable. But in between this flow of information from assessment to policy is a messy world that I would call risk as politics. It involves risk perception, differential values and agendas, questions about process, who is it who's making the decision. Ultimately, that leads to questions of power and trust, and there's a lot of conflict and controversy about risk, and I think that we can understand some of this conflict by looking at this risk as politics element of it, and I'll briefly describe that. So everyone knows that nuclear power has had a rough going over the last several decades. There hasn't been a new plant ordered for decades. We can't site a nuclear waste facility, even though the experts say we know how to do it. It's got a great safety record. It's an important technology. It has not been successful with the public. And I think we have to look to perception and complexity of risk to understand that. So risk assessment science is critical, it's important, but it interfaces with all these other things on the slide that make it a messy business. First of all, even the definition of risk is problematic. I've put up on the screen 4 different definitions of risk. Risk, sometimes we use the word risk when we mean hazard. Sometimes we use it to mean probability, sometimes to mean consequence, and sometimes to mean threat, which is some mix of probability and consequence. I think that's the most legitimate. But I mean, the language of risk, just to begin with, is messy. I've argued that risk doesn't exist out there in the world independent of our minds and cultures waiting to be measured. Danger is real. There are dangers out there, but when we characterize danger with the term risk, then we are imposing models and judgment and subjectivity on this. So I would say there's no such thing as a real risk or objective risk, that we create risk measures through models and assumptions and judgment, which are subjective. I mean, even the simplest way to create a risk measure by counting fatalities and then dividing by some rate is value-laden. People would call this objective, but I would say it's subjective, because counting fatalities gives equal weight to all manner of deaths, whether it's young or old people, painful or non-painful deaths, voluntary, involuntary exposure, and so forth. So even at the simplest level, we see the values creeping into risk. When you get into more complex risk assessments, the values are just as potent. The public has sometimes a more complicated definition of risk than the expert. And the experts tend to look at the probability that something will go wrong and the severity. The public brings in all these other elements, whether there's uncertainty, whether the consequences are dreaded, whether there's potential for catastrophe, how controllable is it, are the risks and benefits fairly distributed, and so forth. So we have kind of a mismatch between the public views and technical. And there are legitimate value issues underlying these multiple dimensions of risk. So I mean, you can't say that the public is ignorant for bringing these things up. There are value questions here that have to be resolved. And that's why I've argued that defining risk is an exercise of power. Whoever controls the definition of risk, what goes into defining risk, controls the rational solution to the problem at hand. So if you define it one way, then one option will rise to the top as the safest. And if you define it as another, perhaps bringing in these concerns that the public has, giving weight to whether it's voluntary or involuntary exposure and so forth, then maybe another solution will come out as safest, or something else will come out as too risky. So that's why we fight about risk, is because there's a softness to it. It's not as objective as we would like to think about it, and there are values underlying the different ways we come to measure it. And so it is ultimately a political concept. So some other lessons. I mean, public perceptions are driven by these values. I'm going to skip some of this because I'm worried about my time. But perceived risk has been studied for 30 years, and we understand a lot of what drives it. In an early study, experts and lay people quantified various risks, and we rank ordered these. And in this older slide, nuclear power was the top of the concern for the public, and it was 20th out of 30 for the a group of experts who did this task. Interestingly enough, you can say, well, people are afraid of radiation, but they're not afraid of radiation when it comes to medical sources. You can see that down the list, X-rays were rather low on the risk hierarchy for the public and higher for the experts. So we're okay with radiation if it comes in a technology that we think will benefit us. That's an important lesson. So all of these qualities underlie the kind of the public's equation for risk, and they're linked to, here's X-rays and nuclear power. You can see they have kind of different personality profiles over these different qualities of risk. And we can then link this to acceptance of risk. Acceptance of risk is reduced if the hazard is new and unfamiliar. And by the way, think about synthetic biology in terms of how it plays out on these things that reduce acceptance of risk. The hazard is new or unfamiliar. Exposure is involuntary. The risk is not under one's personal control. It evokes feelings of dread. It may have catastrophic outcomes. The benefits are not highly visible or fairly or equitably distributed among those who bear the risks. The risk is posed by human failure as opposed to natural causes. We're very tolerant of things that nature does to us. The potential harms are genetic and or delayed in time. The risk is perceived as not well known to science or those who might be harmed. These are all things that come out from other studies, studying other types of hazards. Another lesson is trust obviously is critical, but it's very, very fragile. If acceptance of risk is more important, trust is more central to it than quantitative estimates, says Chauncey Starr, who was a pioneer of the nuclear power industry. It's a key to communication problems. If you have trust, the path is smooth. If you don't have trust, no form of phrasing or presentation is likely to be successful. And it's fragile. You can lose it in an instance, and it takes a long time to recover, if at all. I'm going to skip through some studies we did of this. We looked at trust increasing and trust decreasing events, and you can see the decreasing. What's plotted here is the strength, the impact on trust, and the negative events are more powerful in destroying trust than good things are in building trust. One of up here at the top for the trust increasing, there's an interesting event. The one positive event that one might read about in an area in technology that was relatively powerful for building trust was giving an advisory board of local citizens and environmentalists the right, this is with regard to a local nuclear power plant, the right to monitor the plant and legal authority to shut the plant down if they believe it to be unsafe. So local control and authority was seen as a trust-building event. Acceptable decision processes are as important as acceptable risk assessments, and there's been a discussion, given all I've said about the problems with risk assessment and the legitimacy of some of the public values. We can either do two things. We can restrict public input or we can expand it, and there's been a lot of thought about how we would expand. Excuse me. I could use a glass of water. Okay. So expanding public input. There was a National Academy of Sciences paper a few years ago, Understanding Risk, which argued for an expanded role of the public in risk assessment and risk decision making. And I would recommend that to you if you're interested in how this is portrayed. One last dimension to this. It's more recent and it's quite problematic. We deal with risk mostly through our feelings rather through our analytic capabilities. And this is a natural and it's rational and it's a way to deal with risk, but it's sometimes problematic. So we can think about risk as analysis versus risk as feelings. It centers around something we call affect. Affect is kind of a cousin of emotion. Emotion is very powerful. Affect is kind of a faint whisper of emotion. It's a feeling of goodness or badness associated with a stimulus. It's very powerful in influencing our behaviors. It conveys meaning on information, these feelings. Without feelings attached to information, we don't really understand that information and don't use it in decision making. So affect is a key ingredient of rational behavior, but it can also get us into big trouble. It's linked to understanding of how we think. There's two ways we think. One is intuitively and affectively. The other is analytically, logically, reason-based. Here are the two systems. The experiential, which is affect-based. It relies on associations, images, and feelings linked to these images. The other system is the system of science and logic and law. It's slow, deliberative. These two systems play off in the mind. They're constantly at work in the mind in what we call the dance of affect and reason, which is a lot of research is trying to understand. Images central to the experiential or affective system, and by image it's not just a visual system, it's any of these stimuli that impinge, on the brain. The brain perceives. This image of the last century of the mushroom cloud, it still exists in the minds of a high percentage of our population, and has, I would argue, inhibited the development of nuclear energy technologies. Words have images. It only takes a fraction of a second to get the affective feeling associated with a word. That's a key part of the meaning of a word. One of the things that comes from this risk as feelings is that we judge risks and benefits of technologies by how we feel about them, whether we like them or we dislike them. And that leads to an inverse relationship between risk and benefit. You can see this in survey work. So we have, this is real data, two radiation technologies, nuclear power and X-rays. See, the risk-benefit balance goes the opposite way for both of those. Same thing with chemical technologies. The point here is that risk and benefit reside together in the brain, and if you enhance the benefits of a technology, you will be depressing or reducing the sense of risk. Something relevant, I think, here. That's through something we call the affect heuristic. So positive affect and imagery and perceived benefit reduce perceived risk. Negative imagery and negative affect increase perceived risk and create stigma. Stigma is a concept from ancient Greece. People were marked with a visible sign to show that they were immoral or dangerous. Stigma now in the modern world applies to technologies. Nuclear power and certain chemical technologies are stigmatized technologies, and when they're stigmatized, they have, people oppose them. There's strong economic consequences. You don't want your technology to become stigmatized. I'm skipping a lot here. What about bioterrorism's risks that might become associated with synthetic biology? I would say that they will be taken seriously by the public and government officials, no matter how remote the possibility. This is a consequence of the affect heuristic. The work on affect shows something called probability neglect. If the consequences are dreadful to think about, as most terrorist events are, then the strong feelings that the consequences evoke confuse us about the likelihood. We think it's likely because we feel strongly about it, and that influences our judgments of likelihood. And so there's a lot of work. This is linked, for example, to terrorism. We throw so much money at all kinds of events, things that might reduce terrorism risk without scrutinizing how much we're getting for it because of this probability neglect. Natural is one of those images that's good. That's why we put it on all kinds of products. I don't know if you can. Is the natural vanilla and ice cream, cigarettes made, menthol from nature. So if natural means good, what does synthetic mean? Well, I looked on the internet for synonyms of synthetic, and There's a lot of synonyms out there. They're not very, very positive in terms of, these are like, kind of like potential images for your technology. On the internet site, it also asks, how should we define this, and should we distinguish this from the older forms of genetic manipulation? I think that's an important question, and I would pose it this way. Will differentiating certain genetic technologies from their predecessors and placing them under the new name of synthetic biology promote stigmatization and hinder their development? I think it might. I mean, why do you need a name, synthetic biology, which conveys, newness and unfamiliarity when we know this decreases acceptance of risk? Finally, I would say that many of you already know the important lessons from the risk battlefield, because they're in the objective statement that I pulled off about reassuring the public by encouraging watchdog committees, including representatives of local community, focusing on education, openness, and involvement. Those are all that follow from this. And so this would be best achieved if the public has confidence that its interests are adequately supported and that it has a meaningful voice in making policy decisions. That all fits well with the lessons of previous risk battlefields. And now that you have this knowledge, I hope that you have success in implementing these objectives. Thank you.
Thank you, Paul. That was absolutely fascinating beginning. Our next speaker is Natalie Kuldell, who works in the biological engineering department at MIT. And she's going to be presenting ideas about education that she's been developing with Larry McRae, who is ill. Is that right? Yes, and so unfortunately not able to be with us. And she will be assisted in this by Ken Oy, who, like Larry, is at the Program on Emerging Technologies at MIT.
Thanks. Thanks. So let's see. I was slated to share this. Can we move this to the side? I'll shout for the moment. I was slated to share this time slot with Larry McRae, who generously allowed me to speak first. Larry's not here at all, but Ken will be stepping in to take the latter half of the time for me. Thank you. What I thought I would do is share my impressions as a biologist and an educator, thank you, as I've tried to simultaneously learn and also teach synthetic biology. It seems to me that for synthetic biology to move in a directed fashion, there needs to be an educational mission articulated and also some educational materials developed for that mission. And I don't really mean propaganda, although I think in the interim that's probably a very effective way to go. What I really mean is modular curriculum that can be easily implemented widely and that could also convey the fundamental and distinctive aspects of synthetic biology. And so what are those? What are the fundamental aspects, and how could they best be conveyed and communicated across borders and norms? So I'm going to take a page from the engineers that I know and try to learn from them. The engineers I know are extremely good at using metaphors to illustrate complex ideas. And so I think we've heard a lot of that actually over the last couple of days. There were metaphors like, if I were cooking, it would be with just these few ingredients, or it's like taking broccoli to a potato, or if my iPod only plugged into my computer. And so in preparing this a little bit, I was trying to find the perfect illustrative metaphor for what it is like to be both learning about synthetic biology and trying to teach it. And I have to say that unfortunately I failed. I didn't find the perfect illustrative metaphor, but I did find an illustration. So I'm very thankful to The New Yorker and to clever caption writers who leave me with this, that say there's a bunch of mice in a cage and a man in a large mouse outfit with a clipboard who says, more important, however, is what I learned about myself. And so it may seem obvious, but it certainly is true that in this process of developing a synthetic biology curriculum and learning about it, what I have discovered is that I fall into very traditional patterns of thinking, patterns of experiments, and I'm really very thankful to the wonderful community at MIT that have been both teaching with me and teaching me as we've developed what is at least a first start at some curriculum for teaching synthetic biology. So just to put it in some context, the curriculum that I'll be describing fits into this course that I just finished teaching last week. It is a course that I teach with a number of faculty, including Drew Endy, and I taught this time with Raish Machete, fortunately for me. We teach 4 experimental modules to sophomore undergraduates. We begin with engineering at the DNA level, where they do traditional cloning manipulations. We move on to protein engineering, where they introduce unnatural amino acids into an enzyme of interest. We then move into systems engineering, which is the synthetic biology module I'll be telling you a little bit more about, and finally end the semester with a biomaterials engineering module that I get to teach with Angie Belcher. And the URL for the entire class is listed at the bottom of the slide. So the experimental context that we ultimately decided on teaching around is this one, the bacterial photography system. And I am unspeakably grateful to Jeff Tabor and to Aaron Chevalier, who were instrumental in getting the system working in my teaching lab. So in addition to this experimental context, we support the experimental portion with additional work that the students have to contribute to the registry of standard biological parts, and there is an essay that the students write where they have to self-identify as a member of the synthetic biology community. And I'll talk about each of those parts a little bit. I thought I would step back just 1 minute, though, and talk a little bit about curriculum development and what might have facilitated curriculum development and what might facilitate future curriculum development. It also gives me an opportunity to use words I've never used in a seminar before, and that is top-down and bottom-ups. My natural inclination in curriculum development, I think, can be characterized as top-down. I tried for a while to think about experimental contexts into which we could fit ideas of synthetic biology. And this is a list that we generated at one point of different experimental contexts, different platforms we might try. Light My Wire was an idea we had where we could use electron flow through Geobacter's pili, driven perhaps by proteorhodopsin. Cut It Out was our code for synthetic zinc fingers that were linked to endonucleases, where we might rearrange genomic elements. Yeast Identity Crisis was putting multiple mating loci into yeast. And then actually my favorite, for a couple of reasons, is lucifer yeast, where we would express luciferase in cerevisiae. I think it's a wonderful tool, but in addition to that, Jason Kelly from Drew's lab developed a wonderful logo that we might have used for the Lucifer Yeast project, so thank you. But every time I would go to Drew with these ideas about modular kind of experimental contexts we could try, he would insist that he didn't really care what experimental context we taught this in. And really, so I think his idea was that we could do a bottom-up curriculum development. And he, well, all of us together, generated some ideas about the kinds of materials we would want to include in a curriculum that taught about synthetic biology. And this is not a complete list, and this is not the list that we were actually even able to cover with the initial effort in our teaching. But it does at least speak to the idea that there is a very large substrate of good stuff to teach around synthetic biology that really is very distinctive compared to other aspects that you might be teaching in. Okay. So I'm just going to take a few minutes and talk about the curriculum that we did teach and talk a little bit about the things that might help improve it and also develop future curriculum. These 3 parts, we taught this module. It was 6 sessions over a little over 3 weeks. And each part, it wasn't done in series. These were done in parallel. So I'll talk first about the work that the students did with the registry. We encourage the students to think about standards and to think about the usefulness of reuse. And the students had to register, get an account at the registry, identify and understand what parts devices were, and then finally specify a protein generator that they were interested in. They didn't have to actually make it, but they had to specify it. We also described a little bit about assembly and the power in standard assembly. We talked about physical assembly of DNA pieces, not functional assembly of devices. That's something that is not really teachable yet. I don't know. We also talked a little bit about the cost of standard assembly in terms of people and time versus direct synthesis. And finally, they had to specify a new part in the registry, including documentation about it, but that comes into their essay, which I'll talk about at the very end. In terms of moving this kind of work forward, it would be wonderful if the registry were the foundry that's been described, where the documentation was profound and meaningful, and there were good examples of parts that the students could emulate, and if the wealth of parts were greater. And I think that that will come over time. It would certainly facilitate this teaching. As far as the bacterial photography system, I'm not going to go through the genetics of it and the way the system is set up. I think people, for the most part, are familiar with it. But it is a wonderful system to teach with because it is a lot of fun. And the students certainly enjoyed taking photographs. These are some of the photographs that they took, including a picture, if you can see that, it's a little fuzzy, of their favorite school logo. This is their favorite school mascot, a beaver, and then this is their favorite school hack, which, if you can see, is the Caltech cannon that was appropriated from Caltech and showed up on MIT's campus in time for a campus preview weekend when all the pre-freshmen were there. So they did certainly enjoy using the bacterial photography system and learning with it and having some fun with it. We also asked them to characterize it a little bit. We had them modify some experimental conditions in which the system was working and then quantify that with quantitative PCR. We also had considered trying to implement a two-color photography system where we inverted the logic, and instead of a black and white picture we were hoping to take a black and red picture. The DNA synthesis portion for that failed us. We did not get the DNA in time to actually implement that portion of the module. But we do have a wonderful extra component to it in which the genetics of this system was recapitulated with electronics. So, for instance, the photoreceptor now is described with a photodiode. And they actually physically built these with a breadboard using transistors and electrical parts. And for this portion of the educational curriculum, I can thank my spectacular TA, Rachel Machete, shown here, teaching Lissa and Angie literally the ins and outs of using the breadboard. So that was a pun. All right, the last part of this is the essay that we asked the students to write, which asked them to identify themselves as synthetic biologists. We asked them to come up with a definition of synthetic biology and then fit existing examples from the literature into that definition. They then had to come up with a system that they were interested in building through synthetic biology, and to the point that they could actually specify a part in the registry so that they understood their system well enough for that. And then they had to consider former technologies and future technologies, future applications of the device that they have specified. And this component of the three, I would say, had the most mixed outcome. Some students were completely self-identified and thought synthetic biology was the greatest new thing. I remember one student wrote, dogs should move over, man has a new best friend, and that is synthetic biology. So, not all students were as convinced. This is a quote from another student. Utter the words synthetic biology and no tangible consumer products come to mind. Rather, the word synthetic biology evoke images of mad scientists mixing liquids with arcane names for purposes that can hardly be elucidated to fellow mad scientists, much less laymen. So this student may be not quite as convinced and not quite ready to join in, but this is a quote that's I don't think the entire essay was quite this negative. But anyway, so those are the three components to the curriculum that we developed. It is a first attempt at teaching synthetic biology and teaching, as I say, the fundamental aspects of it. It was complemented by a DNA programming course that Drew was also teaching at MIT at the time. So between the two, I think we gave at least a flavor of the work of synthetic biology. And if I could end with just two more illustrations. One is to say that in the future it would be wonderful if we had a larger toolkit of synthetic biology so that some great tools were available and the students could come in, break something, work with more substrate, more things that truly exemplified and captured their imagination and the things that can be done with synthetic biology. And then Finally, these are the students from this past year, and a quote that I enjoy very much: what we learn to do, we learn by doing, although in the interest of talking about how Moby Dick might be written through Google searches, this, if you Google search this quote, it is attributed to both Thomas Jefferson and Aristotle on the web. So anyway, so Melville and maybe Dan Brown will be writing Moby Dick. Anyway, I think in the interest of time, I'd like to turn the floor over to Ken directly, if that's all right. Thank you.
Okay, and I was actually just simply moving the microphone down in recognition of the 6-inch difference in height. What I'm doing right now is I'm pinch hitting, and I'm pinch hitting for Larry McCrae. If we could pull that up to the first slide, please. Yeah, that's not the first slide.
You just need that, and you advance with this.
What I'm going to do is just move over to here. As you know, all of us MIT guys are masters of technology. Okay, I'm pitch hitting for Larry McCrae. My own appointment is in engineering systems and political science. And what I'm going to try to do is to, in a sense, play Jeopardy. What Natalie was doing was describing a curriculum. And it was a curriculum that's aimed at MIT nerds and their education. Okay? What we found in our first talk was a description of a problem. The problem was risk assessment and perceptions of risk and how it could, in fact, come back and bite you on the backside as a profession and as a field. The task that Larry was trying to address was really to be looking to, if you will, the educational needs of attentive regulators, academics, and NGOs. And those needs are a little bit different from those of the average MIT undergraduate. So let's talk about the policy wonks and what's going on, basically, in terms of the information that might be useful to them in terms of being able to appraise and understand risks and investment opportunities. Okay? If we look at those wonks, they have several fundamental questions on synthetic biology, and I'm speaking on behalf of a colleague who is the quintessential wonk. Larry himself was founding director of the policy division of the NRC, and he worked in the White House and was the head of regulatory reform at EPA. He also wrote the Red Book on risk assessment for the federal government. So he's lived that world. And he's been sitting here over the past couple of days. His illness was not associated with the content of what he was seeing. It was a randomly, naturally generated virus, we believe. But the issues that he raised are these, right? What is synthetic biology? First, and we begin with Jay's definition, all right? Development of well-characterized biological components easily assembled into larger functioning devices. So the question then is synthetic biology a major or a minor departure from baseline work? And to what extent are we using the right timescales in appraising the risks? And finally, what trade-offs do we see across managing issues, capturing benefits specific to synthetic biology while also managing the risks? Now, let's take this problem in terms of perception. And what we have in 1 week, back in October of 2005, was the article that's come up on the screen repeatedly at this meeting, as well as on eBay, this little advertisement for the ABI Applied Biosystem Synthesizer. It may be a piece of junk, it may be great, but it creates a perception that you were talking about earlier, a perception of newness and a perception of things out of control. And that's reflected, if you will, in the attitudes or views of members of the policy community, Ambassador Brill being representative as a good, smart policymaker, interested in trying to appraise risks on the security side, and he observes things are moving very quickly. These breakthroughs, tweaked slightly, can create potentially devastating agents. And then the response of the scientific community, and Phil Sharp, our colleague, is representative of this, is to go through and underscore the extent and the ways that the application of the knowledge could produce good. And then there's another set of arguments that one might get into. on how the application of the knowledge doesn't necessarily greatly augment the capacity to do harm. Now, here's the problem in a nutshell. If you take Ambassador Brill as a student in Natalie's class, potentially, to what extent could he be, in effect, educated to be able to not necessarily do synthetic biology? I can't imagine him running around in Jay Kiesling's laboratory. But to what extent could he be educated to a point where the novelty, the newness, the automatic embrace of precaution is replaced by a capacity for understanding and analysis of the studies? So I'm not going to run through all of the questions. We're running short on time. But what I want to do is just work through bits and pieces of what this might mean as a challenge to this community, because you have an educational mission that goes beyond MIT. If we turn to appraising risks, okay, and this is fairly standard stuff. I was taking notes from the first session. A number of these points came up there. You're trying to sit around and characterize the effects of synthetic biology at the margin on what can be produced, and a lot of this is the same stuff that could be produced earlier. But you're also talking about a set of methods of analysis and production that are going to come together in interesting ways, and that could potentially produce things like differences or independence from sources of genetic material. Now, if you take this type of discussion, and we heard examples of it from the first half of this morning's presentations, to what extent can policymakers' wants, be they in government, in the academy, or in NGOs, be educated to a point where they can appraise or evaluate the arguments that are being made? And that's a fair educational mission and a somewhat difficult one. If we turn finally to a personal note from Larry, all right? Now, he's sitting around and he's worrying about these problems. And he was sitting here, and with his experience, he was noting that there are lots and lots of risks and investment opportunities that he was asked to evaluate over the years, to be working with relevant stakeholders and bureaucrats. And he actually thought that synthetic biology, in fact, was harder to engage with than many of these earlier issues. Now, it could be just a product of his age. But he found the science to be harder, the language to be more arcane, the learning curve to be a little bit steeper, and the characterization of uncertainty to be a bit more difficult. So Larry has been sitting around reading the introductory level molecular biology text at the graduate level. I've been trying to do the same. This is painful work for political scientists. I'm not sure that the President of the United States would ever embark on or engage in this enterprise. But the challenge or the question that I think I would end with is to note that if you take what all of us are doing as educators with our students in the classroom, but expand that a bit to mass publics on the one hand, to regulators on the other, to NGOs on the other. And Natalie, it's not propagandizing, as Natalie observed, but educating to a point where they can reach judgments and appraise information. In the old days, people could read and understand an epidemiological study. You don't need to be a specialist in the field to do that. Or you could read a risk assessment or characterization in the nuclear realm if you're a policymaker, and you can understand that. But recognize that the impediments to understanding and evaluation or appraisal here are in fact quite high. Let me just stop on that note and thank you all.
Thanks very much, Ken. Our next speaker is Laurie Zoroff, who is one of the country's leading bioethicists. She's Professor of Medical Ethics and Humanities at Northwestern, where she's also, I think, Director of Bioethics at the Center for Genetic Medicine. Is that right?
Science and Society.
And Science and Society. She advises pretty much everyone from NASA to the International Society for Stem Cell Research, and she was previously in these parts the Professor of Ethics and Director of the Program in Jewish Studies at SFSU. So, Laurie, over to you.
Thanks.
Reminds me of my son once said to me when we hosted a real bioethicist, who I said, well, we have to be very good now, children, because a real bioethicist, a world-famous Brooke Brody, is coming for dinner. And he said, well, aren't you a world-famous bioethicist? And I explained, no, I'm famous on my block. I'm happy to be here. I wanted to say that I too have too many slides and will probably skip some of them. But I'm also going to do something that might be somewhat peculiar, which is I'm going to re-give basically a presentation that perhaps many of you saw. But Drew Andy said that it was an interesting one, and that for those of you who hadn't, it would be good to see again. And I'm going to lay out the plan of the talk here. I'm going to give a brief ethics test of some interesting questions I think you might want to consider. I'm going to make a parts list inspired by the ND theory of how we should think about this, of classic moral arguments, just so we have those covered, right? So we know that we really hit what we think are the classic moral arguments against the technology. Deliver one hypothesis about why people are upset about your technology, why it's of interest to us in the field of non-science, give a gel slide to prove my hypothesis, and give the traditional plan for further research slide, which I've understood is obligatory, and then thanks. Fair enough? Okay. First test questions. Are any knowledge that would be impermissible to know? Any knowledge that would be impermissible to know? Okay? Don't answer yet. Answer these essay questions. 2, what makes a bad guy? Now, there's a lot of talk about good guys and bad guys. Bioethicists talk about the good all the time, nearly obsessively. I'm a moral philosopher, so that's like our business. Well, what do you mean by that? And why don't we have a theory of evil? And what is your theory of evil? Okay? These are essay questions, right? Okay, this is inspired by Jeff's work. Which thing would be impermissible to engineer from the bottom up, and why? Now, it's of interest to me because I think the key difference here between genetic engineering and synthetic biology is this top-down, bottom-up distinction. That's what's philosophically of interest to me. I just want to let you know. I've written a lot about, because you asked, about biosecurity and weapons, and there is many things to think about. I do think this is the key problem here. And think about this. This is because Jack is beginning to work on that single cell, but think about that interesting papers we heard yesterday, and which of these, how do you go from a single cell to the single cell, a germ cell, a human germ cell, or a non-human germ cell, and then all the other things? Which is impermissible and why? Okay, and if you wanted to think about a specific case, this is the one I tried last summer, about this case, could you make this thing in your lab? All you MIT students. Okay, now this is a good thing to make in your lab. It's an organism that could be environmentally correct, widely useful for human persons. Current treatment for this condition is currently very expensive and has a lot of toxicities and side effects, but you could think of a better way to do it. And that's the core question of bioethics. Can you make the world in the way you imagine? Because your synthetic biodevice has these side effects, right? And these are the ones that people fear and talk about. Manipulating the DNA in complicated ways. Creating an enhancement problem that bioethicists worry about. It's powerful, it's unpredictable. New opportunistic bacteria relationships. A chance of odd chimeric relationships that do not exist, unknown consequences. As someone who works a lot with stem cell biologists, this is one that's been bedeviling stem cell biologists all over the country this last year. And the ecological effects, of course, of your new device would be troubling. Do you go forward with such a thing, and why, and with what criteria? And notice the criteria issue is unsolved, but just hinted at. Okay, then a quick little choice question for those of you who don't like essays. Which is most natural, Time McDonald's or the bird's nest? And then which is most natural, Yosemite or Versailles? Californians should know the answer to this one. Right. Okay, so that's the test. We're going to get back to what I promised. What are the ethical challenges then to world making? What are we hearing about? And I'm just going to give 13 arguments about the problems of sinbio. This is your parts list. These are all widely discussed, and I want to tell you they're interestingly discussed. They're the subject of the open letter that all of us got copies of this week, and an article in the New Atlantis called The Promises and Perils of the New Biology, something that I anticipated in this talk last summer, that there's promises and perils problems. And then in the New Atlantis, which is a neoconservative journal that opposes in general much of new technology, published an article just this last week called The Promises and Perils of Synthetic Biology. It's on the internet right now. And let's turn now to what they said. And interestingly enough, I just want to point out for the social scientists, the genre is of the arguments, of my 13 arguments, appeared in both of the two oppositional articles, from both sides of the spectrum. I think this is a good thing, by the way, in that, like the people on the earlier panel, I do see science as a public act. I do see that we can turn to other examples of how this can go badly, as in stem cell politics, which I think it has gone. It's been a very troubled last 6 years. It has allowed us to think about science issues on ballots, on poll questions. Scientists have been drawn into public debates. Academic science in the last election ended up having petitions about science. There's enormous literature about this that I don't need to rehearse about the fate of science in our public world. So here's the first argument that you're going to hear. You can't touch DNA. DNA is the really real. Bodies are really real, and in fact the body is not only the human body, but also any other body, should be inviolate from the moment it is conceived or created. And our moral status, which is how we treat one another, which is to say that our bodies, and increasingly not only our bodies, but even our very DNA, at the first moment of assembly, is the self, is the ipsity. And to touch it or to alter it, even in the first minutes of it, is an impermissible act. And animals, by the way, and plants have this similar impermissibility of approach. That's a key argument against all of the technology. And one of our colleagues said, in fact, gee, why is it focused on synthetic biology? I want you to know that stem cell biologists feel the same way, and that neuroscientists feel the same way. All three fields in which I'm on in the same early stages say the same thing. Why us? Why us? Why is the concerns focused on us? Second, that dignity is a key thing that we must keep intact. And dignity requires an ipsity. And ipsity requires an integrity. That means that moral status, right, which is the regard we give one another in philosophic relationships, means that if you destroy the human embryo, it's always wrong. But any approach toward the embryo, or even towards the DNA of a creature, is wrong because it destroys, in a way that alters the dignity, the relationship of being and creation. And that especially in the European debates, colleagues from Europe can back me up on this, the idea of fundamental dignity is one that has captured the imagination, the moral imagination of much of Europe. Third, an argument that nature is fixed, meaning nature, beautiful, Gaia nature, human nature cannot be altered. It has clear borders that we just have to observe and respect. It can't be broached without some sort of violation or payback. And in particular here, species boundaries are particularly important to keep very much intact. Nature is hierarchical, in fact, and nature is normative, goes the first seven argument. Nature isn't just a thing that describes the world, meaning it is in fact teaching us about the goodness of the world. And this argument, by the way, bootlegged in from Catholic moral theology, is widely available to those of us right in Gaia theory and many other theories. It expresses itself in a primal harmony. Our use, particularly our machines' use, threatens. And the order to nature is inherently wise. It's even gendered female, I might add, and it's self-correcting. And we saw this actually in the discourse around the tsunami. That from many different quarters, that in fact, whatever you didn't like about the culture of 6 different countries had violated the natural order. We saw that even in some of the right-wing fundamentalist reactions to why it was the hurricane had selected out New Orleans as a city to destroy, because the natural world somehow had it in for the sinful New Orleans. Fifth, and this is an argument that comes up a lot, is that we ought not, in fact, alter the main thing that defines our species being, which is suffering. And then, in fact, the acceptance of suffering is a great teacher of our need, it's a teacher of our love. Without suffering, we become soulless. So whenever synthetic biologists cheerily explain that your goal is to heal, people will come back and say, you want to heal too much. Maybe you want to eliminate disability or eliminate that important difference. And maybe you want to make us live forever. And this idea, in fact, is seen as a problem, not an advance. 6 is slopes are slippery. This is an undergirding argument of much of the philosophic argumentation against your field. That in fact, if you start doing nice thing X, right, you'll end up really rapidly at the very bottom of the slippery slope. Now, let me tell you one thing about the bottom of the slippery slope is, while sitting here as a philosopher and listening to the complexities of your research, the elegant complexity of your research is really hard, Arguing about the bottom of the slippery slope, you know, Frankenstein, clones, blah, blah, that's a lot of fun. And there I have as much expertise as any of you. So your random neighborhood philosopher will tend to pull you right down and have you arguing with me on the bottom of the slippery slope instead of the present time where you are. And that eventually you'll be like cornered like the stem cell biologists who have to defend the fact that they really don't want to make cat food from the embryos. And people engage them in those sorts of debates. Seventh is dual use. Now, dual use is inevitable, and we've spent an entire morning on you, and this is it. The bad guy, evil people will turn whatever you make for good, even great good, into weapons. Well, yeah, that's true. And in fact, our species tends to do this. You know the story about why the French didn't think the British should be trusted with forks, right? Because they thought they wouldn't be able to eat with them without stabbing each other to death. And the history of our species includes deep genocidal actions, to be sure. As a Jew, of course, I understand this deeply, and they always think that this dual use is a powerful argument, and we've seen it talked about. Eighth is that mistakes are inevitable. Need we say more after 3 Mile Island? And of course we can. And anyone here can give us a litany about all of the things we've done profoundly wrong with cheery good intentions or releasing the wrong thing into the atmosphere. And yes, are you going to make mistakes? I can tell you one thing about your work. You're going to make a mistake. Okay? It's going to happen. Inevitable. 9, finity and contingency define us, not mastery and control. Many people, even the people here who are cheerful about your work and generally optimistic, as I would count myself, do get a somewhat uneasy around technology that is about mastery. And the more you feel confident and excited and happy and powerful about your work, the more people in the humanities will begin to cringe about the very applications of that mastery. Linked to this issue is 10, we will be as gods, right? And people say this a lot. In fact, the quote, fine aspirations acted upon is the core of happiness, is a quote from Leon Kass, who guided the President's Council on Bioethics through the first 4 years of its existence. And the idea here is that there's a slippage between God and humans in antiquity. It's a Greek fear that the more power that you display, the more dangerous you will become, okay? 11 is the one that, you know, I'm from Berkeley, so I can tell you this is a powerful engine against the research, and we can see here is a little, this example, which is thanking all your many sponsors, which makes your many sponsors happy, makes many people quite unhappy. The idea here is that the marketplace is so powerful that here is the opposite from that you're going to make a terrible mistake. It's you're going to be incredibly successful, and therefore you're going to have a lot of money. And as David Baltimore said before, this has happened in the past. Hence, there's an inevitable miss of the marketplace and science, which for many people is troubling. It spells trouble, right? And that even good scientists could be tempted by profits promised by Big Pharma. This links directly to the first question of where do you think evil comes from, okay? Conflict of interest, the whole literature in bioethics about conflict of interest, and what happened at the NIH around conflicts just should alert you to the fact that this fear is real and has regulatory teeth. 12 is the one that I think is these are important issues, all of them. It's an unfair world, and you're doing an unfair thing, a fair thing in a small way, but unfair because of the distributive possibilities for misuse. And many people, in fact, someone already said this here, why are you working on such fine-grained solutions, not just making better water for the masses of the earth? An interesting and important question, and that the classes of haves and have-nots will be accelerated by your technological advances. Say 13, it's in synthetic world, the previous speaker about risk showed this, that to make something synthetic is to be duplicitous, it's to be a fake, it's to be immoral, and that inauthenticity is by itself, in a philosophic way that is important, violent, because it's the violence of its creation is its displacement of the real. And that's a point that I think we could spend a lot more time on. I just want to reference it here. What can be said about these challenges? And you can take any of these parts, but 3 things we know about these arguments are true. They're old arguments, they're very long-lived, and all of the claims are true. They're real, they have real validity. Most of them are much more than trivially correct. And in some circumstances, any of you would agree with these issues. The issue here when it comes apart is when we go to the extremes on these arguments. Yes, slopes are slippery, but haircuts are possible, just to give one example. Secondly, the other thing you could say is true is that new alliances are proliferating just as quickly as other things that you're making in your labs. These new alliances happen this way. Not everybody makes every claim of the 13. Some of these claims are left-wing claims, and some of them are right-wing claims, and they do agree about the danger. 3, many of these claims, in fact, perhaps all of these claims, are not good philosophic arguments, say I, the philosopher. They're faith-based arguments. They're religious statements about the end time. They're statements of faith, worldview, and eschatology. They're not moral arguments based on rational discourse that can be proven or disproven. And as such, because they are about eschatology, they can't be agreed upon in a pluralistic democracy. Such concerns actually reflect something quite more interesting and deeper things. What's not being said is that they're classic tropes, largely of Greek philosophy, that the world is very scary, it's mutable, it's unfixed in its borders and caprices, that Pandora is trouble, which is you, that God-person boundary is at stake, and finally the one that we did see, and it is from Aristotle, perhaps Jefferson knew Aristotle, something about Aristotle, that to know is to make, and the implication of knowledge and making, the inevitability of that. There's also classic fears of modernity that plot against the classic fears of antiquity, and these are they. You can look at them here, that somehow these ideas that you've unfolded are like pieces in a garage, in the Hewlett-Packard garage. You've spread the world like a Legoland in the garage, and people fear that you won't be able to put the thing back intelligently. They fear that you think of the human as a sort of a machine, and moreover, then this creates the possibility that there is no real at all. It could all be deconstructed and reassembled, perhaps in more interesting, even more intelligent ways, which, while intriguing to the community, is destabilizing to the watchers. Now, this leads me to think that of all the many things, and there's 700 more we could all say about this, the core problem here is that, in my hypothesis, is that the reasons that this has such cachet, this works so well for the society right now, is that it hooks into a metatrophic synecdoche about this time that we are in. There's a transhistoric and transgeographical turn to fundamentalism at the moment that we are at the threshold of serious new ideas in science. This is not new, this phenomena, threshold and fear and reaction. It's just powerfully a part of your work now. Now, there's many features that you can see repeated from the 9th and 12th century, whenever this happens, repeated now. This sense that there is forbidden knowledge, that there's a hierarchy of natural law, that suffering was redempted, there's a fear of plagues, there's belief in an end time, mysticism and spirituality are on the rise. There's a view of women in many cultures as dangerous, should be hidden. There's a lot of conspiracy theories. There's this idea that sin is linked to disease. We see this even in the obesity literature. These are powerful tropes about this confrontation. That the idea that there's instinctual knowledge is the moral core of our wisdom is one put forward at the President's Council by Leon Kass. It's called the yuck factor, or the wisdom of moral repugnance. It's an old idea. And that the idea that the wealth is really in the land is one that's quite powerful, that there's an unease with cities and markets. Now, this is my gel slide to prove that, in fact, I believe this is happening now. It's Da Vinci weekend, and it's why is this whole idea so powerful, or The Passion, or the book series, or country western music. Other gel slides are apparent, right? Notice this last one, by the way, because I know that Paul's going to talk about this. One of the people at Stanford, Will Hurbutt, actually says, many of us are worried about the Enlightenment. So. Science is seeing. The Enlightenment is light. It is knowing, witness, and presence. The narrative of modernity has always opposed those medieval sets of ideas. These are the core ideas of your work. Time and space can be quantified and measured. The actual world, it really exists. It can be understood. Science is technica. Science is phronesis. So, okay, quick test results. Is there anything, just a little show of hands, is there any knowledge that should be completely forbidden? Guys, right? Okay. What's natural and what's not? Practical wisdom. Look at that bird's nest again for the natural. Look closely at the bird's nest. Okay, see the plastic? Okay. Okay. Would you make the organism? That's it. It's a horse. I was describing a horse. Right? Okay. many of the ways that I want, we have to know to wrap up. I have a couple of things about wrap up. There are some things that you might try here that are going to fail. One thing that's going to fail is to think about using the precautionary principle. I'll tell you it's going to fail because we just saw this happen with nuclear energy. Most of you know this. The reason it's going to fail for a philosopher is that every single moral gesture, and you're doing a genuine moral gesture, leads to a future that is fundamentally unknowable. Not doing it doesn't keep you safe or keep you in the same place in history. It just opens a different door to the next historical step. So this is not thinking that if you just don't do something, you're going to be safe or stopped in history is not going to work. These are ideas that we came up with in AAAS about the real things you should think about. And again, these are 4 questions that I think are the reasonable questions to ask about new technology. And colleagues who put them together at AAAS when I was on several panels, not just the stem cell one that was referenced, but earlier ones, think first you should ask about reasons in principle, then reasons about context that should be taken into account, what sorts of purposes you want your work to be used for, and what procedures and structures, all the overlay that you spent the first morning thinking about. Those are the 4 things that you actually have to solve. I don't know how they're going to be solved for this technology, but I do know those are the ones to think about. I'm primarily interested in 1 and 2. Now, you make the world? That's the question I want to leave you with. Perhaps not. There are many forces that will oppose this effort, from Jeremy Rifkin, Leon Kass, to the new Pope. These are 3 powerful forces that speak against it. And you have to think about why these arguments, they all use some of the 13 that I mentioned. I think the answer is obviously yes, but as we said earlier, please be good and careful. We have a strong American pragmatic philosophic tradition that says do things slowly and incrementally. Think about practical aspects of your work at all times. I would turn you to those people. There's normative directions. I'm going to skip those. I can tell you why and how to be good, but all of us say the same thing, right? Serious discussions about implications, they all say the same thing. We look for categorical imperatives. I think these are 3 things to think about. What can you know? How ought you to live? And for what can you hope? These larger sorts of questions, right, that Kant puts forward. I still think these categorical imperatives from Immanuel Kant in 1788 are useful ones for your field, right? These 4 ideas about how to be good, I think could animate the field as you go forward. So you face a few more issues. I'm sorry to be going over, but I just have to remind you that we are not at a Silomar, and here's a few reasons why. The morning displayed this one, but other aftermaths are also important. We're after Katrina. Think of that whenever you want the federal government or engineering to solve problems for you. We're after the post-Korean lab scandal. Think of that when you want to trust the absolute reliability of published research. We're after Enron, right? And Merck, one might add. Government, science, and the marketplace, 3 places that we turn to for regulatory oversight have faltered since the Silomar. The stem cell wars should teach you a thing or 2 about public bodies. The stem cell wars at this point are up to the National Academy of Science, which just last year said we do need public oversight. We see something called escrows at every institution and something that they call RAC-like bodies for general oversight. And finally, the evolution debate, also very different from a Silomar. It's also in its 2.0 stage, religiosity being a new factor. Lots of models about how to be good. You can try systems and rules and software and stuff. You can try moral agency. You can try something that I've written about in the paper that's outside about what it means to be good as an individual citizen in a lab, something I call the Jedi Knight concept. We can talk about that more at later. I believe that you have duties that precede your rights, and that's just a statement I'm going to make about normativity, and I can defend it later. Stanley Brenner gave you 2 things to think about. I want to end with one thing. When you work with ethicists, you remember that they have duties as well. And I think that's part of the thing I just want to put in here out of sort of humility. And you have to learn this science. You have to listen carefully before we tell you what to do. And of course, further research, I think, should be aimed, for my part and for your part, towards this fundamental issue of healing the broken world. David Baltimore called for it yesterday. I think we need to return to that as the goal of the thing. And finally, thanks, everybody, for inviting me.
Thank you, Laurie. Our last speaker is Paul Rabineau, who is a local boy, professor of social and cultural anthropology here, a man who works, he says himself, on problems of modernity, power and knowledge towards developing an anthropology of reason. He's got a particular interest in the biosciences with a string of books coming out of his fieldwork. Some of you may have read Making Peace TR or French DNA, or indeed A Mission to Make a Future. Paul.
Where do I press? Okay. Thanks. Okay, thank you for having me here. I have very many fewer slides, so maybe I'll be close to the time allotted. On the one hand, on the other hand, there are about 400 things I'd like to talk about that have come up, and I won't get a chance, so I'll stick to my slides. However, I can't resist the fact that the two things that were said about Aristotle I think are fundamentally wrong. The first line of Aristotle's metaphysics is all men, anthropos, by their nature, desire to know, and the end of knowing in the metaphysics is contemplation. It's not making. So we could talk about that another time. Okay, but it's the point of that at some level is knowledge is distributed. The overwhelming amount of knowledge in the modern world is a problem and a challenge for all of us. So this is a small example where who cares what Aristotle said, except that if you're doing certain kinds of things, it happened to be wrong. And Aristotle and the Enlightenment are radically different things, and we won't talk about that, but we could. Okay, my goal is thoughtful action, and the first and maybe the ultimate moral punchline that I have to deliver is the age of the individual research effort in the social and human sciences is over, and that whereas in the biosciences and other of the natural sciences, you've learned to develop multiple collaborations on group and sustained projects, this has not happened in the humanities and the social sciences, and with the 21st century dawning already with us, it's time that we start doing this. Otherwise, we will be relegated to the sphere of values and have nice long talks, which the businessmen and women and the makers of this world will all ignore. So we are trying at Berkeley and in relation to a number of other friends and colleagues to set up a research collaboratory in the qualitative social sciences. And if you want to read about our initial efforts, you can look at anthroposlab.net. We've run a series of experiments in this, most recently hosted at the Molecular Sciences Institute to try to make us feel like we were actually having lab meetings in the social sciences. Okay. Point one, specificity, and this comes back to Tom's point in an ecology of ignorance. In an ecology of ignorance, as I said 2 years ago at the first conference, is the milieu in which we live. We do not know where things are going, and the first criteria and the first ethical demand is to accept that condition and to begin to think about what contingency and uncertainty and the demand for action entail. If you get too many claims about certainty and specifically about planning modes, I would argue at more length and in another context that you're actually not being true to reality and that you're very likely to make mistakes. So the European bureaucratic models of planning, which were developed for other forms of problems, most importantly social security problems, are likely to be radically misleading in certain domains of the contemporary world. So it's a caution against planning and an attention to the kinds of contingency and uncertainty and demand for action in the world we live in today. So there's a first distinction to make, which I also made the last time, but which I'll repeat quickly. There's an important distinction following a version of what Paul's excellent talk this morning, which covered this ground in much more detail. Again, this German sociologist Niklas Luhmann makes a distinction between pairing risk with security and risk with danger. If you pair risk with security, and we've heard a certain amount of this in the presentations, then you think you're going to arrive at a state in which things are secure. And the point of risk assessment and risk analysis is to get you to that point. The only problem with pairing risk with security is it's a fantasy. So it's more important and more accurate to pair risk with danger. And I won't go through this at more length because I think many of Paul's slides pointed in exactly in that direction. There are dangers in the world. When you make them probabilistic, quantifiable, and actionable, then you're talking about risk. You're not talking about security. You're talking about risk assessment, and risk assessment is, as Paul argued, embedded in politics. Okay, then on to the issue that Tom raised, I think, which is really crucial. What are the risks and dangers that apply specifically and uniquely to synthetic biology? Because I think the great danger that you're getting into, or you could get into, by your visibility and by your well-organized community and by the dynamic acceleration of discoveries and what have you that are going on, is that you can become like stem cells, too visible, and have to carry the weight of many questions which are only peripherally connected to what you're actually doing. So a little bit of self-deflation would probably be a good idea as you move forward in this very exciting enterprise, which I think all of you know I'm extremely enthusiastic about, being an enlightenment type to the hilt. Okay, so let me give you another example, the HAP map. Okay, you're having all this big ethical conferences about synthetic biology, whereas it's not yet clear to me that there are any issues that have emerged yet, but we could keep talking about that. But take the HAP map. This is a U.S. government feel-good project after the genome sequencing projects, as you all know. Francis Collins and his friends, Mr. Ethics, with the biggest ethics project in the history of the world, decided that they needed to do something with all this energy, all these bureaucracies, so they're doing the HAP map. Now, there's a lot of scientific controversy about whether it's worthwhile or not, but let me just point out that the HAP map is not being attacked by the right wing, the left wing, and everybody else, because after all, it's about health, and it's done with appropriate ethical considerations. But I would argue, and I could do this in more length, and completely unrehearsed, the example we had earlier in the morning about the South African project, that if you think about it, the HAP map is probably one of the most dangerous and risk-filled enterprises that Homo sapiens has ever undertaken. It's going to provide a map of all of the specific pathological regions of the populations of the world. It's extremely likely, as Roger will smile about, to reinscribe race after a century of uninscribing race. It's going to give, in public knowledge on the website with ethical approval, exactly the conditions which separate people and make them vulnerable to new forms of pathogens. Now, I'm not saying don't do it, but I am saying that arguing about whether or not Artemisian is a major ethical issue compared to the HAP map strikes me as something like a political and rhetorical mistake that you've been making, that you ought to try to redirect attention to some other arenas. That's point one. Point two, there are three modes which need to be differentiated in what you've been talking about. And I call these safety, along with my colleagues in this collaboratory, safety, security, and preparedness. You've mainly been talking about safety, and that's, of course, good, and you must continue to talk about that. There's been some talk about security, and security has been equated largely with terrorism issues, and we can talk about that more. But the real issue, it seems to me, is preparedness. And I'm talking again about a mode. You need to do all three of these. You can't do one or the other. But I think too much attention has been paid to safety and security and not enough to the mode of preparedness, although the disadvantage or the advantage of talking last in a long day is that many of these issues now, in one form or another, have come up. Okay, a few of the diacritics of preparedness. One, preparedness turns on low probability events with high consequences. So if you're building entire databases around extremely low probability events, you should be clear why you're doing it at the very least, okay? And there's been a lot of slippage and confusion in the discussions about whether the risks that a lot of the technologies you're proposing would be would enable you to identify the risks, whether or not those are the risks you want to be able to say are central and important to what's going on here, or that these are very low probability chances of happening, but if they do happen, the consequences of them are enormous. So I think there needs to be some more thought about that. Second, as several people have mentioned, preparedness deals with events that are foreseeable but not predictable. Okay, so hurricanes in the southern regions of the United States during certain months are foreseeable, but the exact scale, location, and consequences of those hurricanes, not to mention earthquakes, and as you all know, if you live here, and you may not know if you don't live here, you are now on the Hayward Fault as you sit here. The fault most likely to go off in the Western Hemisphere with the most major consequences, so welcome to California. The foreseeable but not predictable phrase has a lot of technical jargon behind it. What it means to my group and the people around us is we're not dealing anymore in preparedness questions with insurance issues. Insurance issues turn on a long series of events, started with commercial shipping and the rest, but it goes into other disaster forms too, in which you can make calculations as to probable events and probable consequences, and operate therefore in insuring against what's going to happen and the possible losses that are going to obtain by that. In preparedness, you don't operate on an insurance rationality. You operate on a rationality which says, as we've just heard, things are going to happen. And the principle of rationality of preparedness is prevent disasters from turning into catastrophes. Okay? So a very low probability event, such as somebody using one of the pathogenic sequences that's in the database to do something nefarious, could have immense consequences on the future of free science in the world. And therefore, one of the things that you should be thinking of in addition to what kind of technology you can use to secure your synthesis enterprises is what happens when this happens. And that there's a sort of proactive acknowledgement that there are going to be accidents, there may well be events of nefarious sorts which are going to have at one level or other implications for your community, and the question is, how are you going to begin to anticipate that and respond to it, including arguing about the distribution of risk and responsibility among other parts of the biological, natural, and other scientific communities, and saying this is part of what maturity is. There isn't a totally secure world. The world is going to be dangerous, and we're willing to take some of that danger upon ourselves and some of the responsibility upon ourselves, but not all of it. And that leads to a general mode of vigilance. A lot of what you're hearing is an uneasiness about whether the technological answers alone are going to protect you. The answer is they're not. That doesn't mean you don't do them, but it does mean that also a form of distributed community vigilance, which can start with a code of ethics, can have other dimensions to it, but requires an ethos within the community of a certain kind of maturity which says, first, we believe and passionately want to defend free science. Secondly, what we're doing may well have some good implications for health and the rest, but it may not. And third, there are risks involved in this, and some of them are unforeseeable. And furthermore, in a free democracy in the 21st century, that's something we need to live with. 5 minutes. I'm almost done. I'm actually on time. And finally, then, this leads me to my enlightenment theme, or what enlightenment amounts to in the 21st century, which is to say, in many places in the world, but let's stick to the United States, the future of free inquiry, both in the natural sciences and in the human sciences, Geisteswissenschaften, is very much under threat, both from the right and the left, in various ways and in different forms. There's a massive anti-science and anti-technology ethos, which is extremely widespread. I passionately and radically do not share this ethos, and I think that we need collectively to figure out ways of articulating the genuine curiosity and enthusiasm and commitment And as Drew pointed out, the willingness to make a little video clip at a Saturday night at 10 p.m. Because good scientists, as Tom White, one of my friends and informants from Celera, said, any scientist who leaves work at 5 p.m. has given up on science. You're passionately interested in discovering and knowing things. I'm passionately interested in knowing and discovering things. And we're under threat. And we need to be serious about both not making false promises, but also articulating better why it is that understanding, and here's where Aristotle does actually come back, although also John Dewey and a few others, is an essential quality of what the good life is. And stop promising that you're going to cure cancer alone, but also say that unless we're allowed to think in a free and open society in a sustained and responsible manner, something absolutely essential about what the good life is will be compromised and lost. And I'll close by referring to the 1915 document of the American Association of the University Professors, which is the first document to define free academic freedom. Academic freedom, this was during the First World War when the president of Columbia University announced that anybody in the faculty who did not support the war was fired. And the only person in the history of the American Anthropology Association to ever be thrown out of the association was none other than Franz Boas, who was not the founder of American Anthropology and the only person to ever be thrown out of the association because he denounced some of the spying efforts that were going on. But the key point, and this has come out recently by a constitutional scholar, Robert Post, who used to be here and is now at Yale, academic freedom, free inquiry, turns not on some doctrine of individual free speech where everybody can do what they want to do because they're protected by the Constitution. It turns on corporate, that is to say group, not business, corporate responsibility to produce knowledge that generally increases human good. And unless we find ways of re-articulating private interest, security questions, the bigger ethical questions, along with a rapidly transforming university situation into a new form of encouragement for free inquiry, we're all going to be in great, great trouble. So keep up the good work, don't make false promises, and don't leave the lab at 5.
Thank you very much, Paul. As you'll agree, those have been far better presentations than the moderation has been, because the moderation has left us somewhat over time, which we're going to deal with by slightly curtailing lunch and also by running probably a little bit late into the afternoon, but not very much. But anyway, we do have time for a short question period, if audiovisual allows that. We have time for a short question period, in which I think I will start off by taking a small handful of questions to get us started and then going back to the panel. So, Peter. That's probably good, but may have less involved.
It's an observation, really, rather than a question, and a plea. So, Peter Alders, I'm from New Scientist magazine, so I'm somebody who uses words for a living, and I think words are quite important. But this is a session on understanding and perception, and in understanding perception, I think it's also going to be publicly webcast as well. Now, in understanding and perception, words seem pretty crucial to me, and I just want to make some observations on good words and bad words. So, in the field of synthetic biology, if you're talking about communicating to the public, what's a good word? Well, what's a bad word? Transcription terminator is probably quite a bad word, but part is quite a good word. Repressilator is probably a bad word. Device is a good word. Now, I heard some other, I actually had to write these words down, and I don't know what they mean, so maybe, and I don't know what the good words are, but we had today eschatology, or eschatology was it? Phronesis, hermeneutic circle, and I think metatrophic synodoche. Help.
You want to take the question?
No, I'm going to take a few. Sorry, Eric, are you giving us?
Moving to the microphone.
Yeah, please.
We have pen, Paul. So my question is directed to Laurie, but any of the panels can address this. I'm an evolutionary biologist. I teach evolutionary biology, and it struck me a lot of what you presented were facets of the evolution wars, and I wonder if you could expand upon that a little bit in terms of the lessons learned from that, or the battle scars that have been gained from that, in terms of how synthetic biology or bioengineering can proceed.
Okay, well, while the rest of you think of your questions, or possibly your lunches, I'll turn those back up to the panel. So we have evolution and we have language. Who'd like to? Paul, did the language point resonate with you?
Yes. In addition to the words being understandable, they carry associations and images which are linked to feelings. And one of the ways in which we think and respond to the world is through the feelings that are evoked as we confront these images. And so I was just trying to raise it in my much too quickly presented talk the notion that one should be alert to this type of thinking. I mean, we all think this way as much as we might want to be analytic and reasonable and think logically. We also think quickly, intuitively, and through associations and images that are linked to language. So language is critical, and one needs to be careful with it.
Paul, anything to say about language?
Two quick things. First, the language issue is real, but you must remember as well, and this is something we joke about all the time, that it's perfectly fine to use scientific jargon, but it's not fine to use words like eschatology, which are appropriate in certain kinds of audiences to sneer at. But I can assure you that eschatology, which is after all a biblical term, is understood by more Americans and Brits than all of the words you use together. So there's also a question, therefore, of, and as a political force that's as great as the Enlightenment in what's going to shape the future, both of the media, by the way, and free scientific inquiry. So that, for me, is an issue then of the great breakdown of the educational systems of Western Europe and the United States, in which a common education of some sort, which includes the Bible and Aristotle, as well as Darwin, is a great crisis. So I'm really relatively unrepentant about that, and professions of talking for the common man as a profession of ignorance and a certain policing is not something I'm very sympathetic to.
Ken, how performance like that?
Not very well. No, actually, I do believe that at least many concepts can be expressed in plain language, both in the realm of policy, in the realm of perception, and in the realm of science. Most, but not all. The reason why I delivered that charge or that request, that challenge, if you will, on education, is that when we get down to the particulars of what is required to be doing synthetic biology and appraising what it's useful for, there is a bit of specialized knowledge that is required that needs to be communicated more efficiently. And I would just leave it at that.
And Eric's question was really directed at you, Lauren.
Unrepentant moral philosopher. There is a way that ethics can be reduced to training. And there is, and all of you know this because you've all been forced to be PIs and take this dreadful web-based training in ethics. And so, as you'll note, I did intersperse my slides with "be good, tell the truth," right? And a simple version of Kant's categorical imperative: don't kill yourself. So I am capable of saying this in very simple language: be careful, don't kill yourself, be good to the stranger. But there is a way in which it is important to me that we're not doing training here. We're doing serious and rigorous work in basic research, in the basics of moral philosophy, which is an extremely old tradition that allows me and Paul to fight about what did Aristotle say and in what what text, he said, that is as old a tradition as looking at biological organisms. It's often presented as the soft stuff, and I don't want it that way. I'm not interested in that. I'm interested in displaying and in teaching the serious research that I need to do about why it is that certain ideas and certain feelings and certain things seem to make sense to you and certain ones don't, why these tropes and familiar memes reoccur in philosophic texts and in the popular culture. It's why I go, actually, with such attention to popular culture. That's why eschatology, which is a word that means end of days, there's a series in American novels, most important religious book that you could read about your American colleagues, is the Left Behind series. The Left Behind series has sold more copies than any other text in the United States in recent years. And it's a series of 15 novels, I believe, having actually read them all, about what happens in an eschatological world at the end of days before the second coming of Christ. And it is widely read in the United States as an actual account of the possibilities of the next several years. It's an important thing to think about.
In the White House as well.
In
Ken.
the White House.
Ken, you had a point to make.
Phronesis just
Sorry,
means
Ken
practical
had a
wisdom.
point to make as well.
I'm sorry, Ken.
It's actually a very, very short point. The discussion we've just had does underscore the need for basic education, and I use that word or embrace that word deliberately, in arts, philosophy, sciences, and mathematics. If we look at the American educational system narrowly or broadly, there are a number of deficiencies, and those deficiencies are being compounded to a degree by the need for some specialization. But I actually accept Laurie's point that you're not interested in training people in ethics and public policy. We all have seen, let's call it scandalously bad work done under that rubric. But the notion of training people in the basics of philosophy would be useful for all of us as citizens, just as training, education would be the better word, education in basic science is actually probably the cost of entry so that our policy wonks may understand more fully the work that you do. We had Ambassador Brill up visiting, and one interesting thing that came out of it was that he expressed an interest in being educated by Natalie and having his staff educated by Natalie, so that they wouldn't necessarily be taking things on faith, so they would understand may be the right word, a little bit more of the issues, be in a position to engage in independent evaluation, trusting the experts, but not entirely.
I want to say that the science that you do is at the highest and most complex levels, and you don't take any prisoners. You do it in a very serious way that I respect. We're here because it's interesting, and we have respect for the level of complexity of the work. And you're allowed, and I respect that you make up new words to fit your new science. So when we honor you by our...
Okay, I think
that,
we've had
we
enough
got the
on
point.
the,
You
we've
get
had
it.
enough of
He's
the
agreed.
words.
Okay.
We've had enough
So we're
of
done
the
with
words.
words. Can we move on to
No, I'm
evolution
afraid I
words?
don't think we can move on at all because I'm being told
Okay.
to wrap up because we've run on too long. We have one question waiting to ask. John, is it a question?
Did we
Yeah.
go to the
comment?
evolution?
It's a question,
Brilliant
actually.
assertion.
Okay,
No, it's
Is
a
it
brief,
very quick?
It's a very quick. It's mostly
Go.
for Paul. And I was wondering if you had any other examples like the HapMap example where some group has possibly found a way to not get all the attention from their system, because we have lots of examples where the GMO crowd has screwed up or something, but if you had any other examples, that would be just useful to think about.
We should talk about it. I think there are quite a few, but this is in line with Laurie's point. The ELSI model, which the government has worked fairly well, was 3% for science and ethics after the science is being done, and with massive political presence in Washington. And those disappear from the screen because they're certified. But I think my point was not against it, but to say that it's not the model that I think is going to be suitable for this community. The genome projects were technology projects. They were basically sequencing projects, and with enough time, money, and labor, they could be done. You guys are doing, where you're going exactly is far from clear. You can't promise with X million dollars in 2 years we'll do this. So the ethics, which is to say reflective thought about what's going on, can't come 3% afterwards. So we're grateful we're here, and we think the challenge is collaboration of a new sort, not the ELSI sort, in which, as the issues emerge, they will only emerge by having discussions around the specificity of what it is you're actually doing. And that's the way to avoid being thrown into the stem cell debates and cloning and the rest, to say, no, that's not what we're doing. What we're doing is, what Jay's doing, and here's how it works. But you need other people around as well to talk across disciplines and across boundaries and across publics, because there is no such thing as the public or society. Okay? There are multiple publics, there are multiple social groups, there are multiple social movements, and it's that complexity which we may be able to contribute to in a collaboratory manner.
Thanks very much, Paul. I'm going to have to wrap it up now. We're meant to be back here at a few brief announcements, if you will. We're meant to be back here in 45 minutes or a bit less, frankly, but at 2 o'clock. Lunch itself, back here at 2. Lunch is more or less where we were last night, but you go there through the nice, airy courtyards rather than going back out onto the road. I'm told if you are presenting this afternoon, please come and put your bites into the machine that wants them. And if you are a member of the working press, Jay and Drew will be meeting with you in the room across the hall during lunch. And also, a great deal of thanks to a really excellent panel and 4 excellent talks.